expanded octet video. Okay, so first thing I need you to do is make sure you write these down. So if you need to pause the video, pause it, but I'll go over them with you. All right, so an expanded octet, first thing we need to know is up until this point we've said everything needs 8 valence electrons and can only have 8 valence electrons. Okay, so that's almost true. Sorry, I kind of lied to you a little bit, but not on purpose. Well, on purpose, sort of. But okay, so atoms with atomic number under 20 combine to have 8 electrons in their valence shell. That's common. That's the octet. Okay. Now, in some cases, the octet can be expanded by some elements by utilizing the d orbitals, and some of the commonly ones that do this are sulfur, phosphorus, silicon, and chlorine. All right. So like I said, I told you a little bit of a lie and told you all atoms had to have 8 valence electrons. Well, the octet still governs what happens to electrons. However, sometimes we can utilize these d orbitals in a way that kind of gives them more options, and we can kind of basically expand our octet, and we can kind of what's the word I'm looking for? I wrote this down. Have access to energy levels where now I can't think of it, but I'll come back to it. But yeah, I'll come back to it. But I'm not drawing a blank on what I was trying to say. Cheat the system. That's what I was looking for. Cheat the system. Okay, so how does this happen? Well, I told you that that we have some hybridization going on in the last valence electrons. Okay, so how do they get to utilize these valence electrons? So here's what basically happens. Okay, all atoms can only have. Oh, sorry, take it back. Let's take a look at sulfur real quick. Sorry, I'm just kind of missing my notes here. So sulfur is in what energy level? If you look on your periodic table, which you all should still have one at home or have someone have it accessed, you'll see that the electron configuration for sulfur is in 3p. Okay, it's in 3p. But once an atom gets into the 3rd energy level, if you remember our electron configuration, there's 3s and there's 3p, but if you continued on, if you remember it, the next part would be 4s, and then we'd have 3d. Okay, so that 3d is on the 3rd energy level. So what sulfur has is, even though it's using the 3s and the 3p, it still has access to the 3d because it's on the same energy level. Okay, so what happens is sulfur can send some of those electrons up to the d level, to a d energy level, and kind of cheat the system a little bit and not have exactly 8 in its outer shell. Okay, so it kind of expands on the octet. Okay, so let's see what some of this looks like. Shall we? Yes, we shall. Okay, so let's look at this one. We have Br. We're going to use BrF3. And right now you're going, well, that looks like it could work because it has 3. But let's think about how many electrons we have to use. Now, if you're going to try to cheat the system and think, oh, I can do this one, it's just Br, 3 attached to it, blah, blah, blah. No. You got to remember to do this. It has 7. This bromine has 7 valence electrons plus 3 times 7 for fluorine. Okay, which equals 28 electrons divided by 2 gives us 14 pairs of electrons. Okay, now I'll show you why this kind of where you're going to have some issues. Okay, so between this, you know that Br is going to be in the middle, and you're going to attach fluorine to 3 sides like you would normally, because you know these can make one. The F's can make one bond. Okay, so we're going to subtract our 3 from 14, and that leaves us with 11 more electrons. Okay, 11 more electrons pairs to put on here. So let's go ahead and put those on there. I'm going to do pink. Okay, so I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9. All my fluorines have 8. Let's give 8 to bromine. Okay, that's 10. So now I have 3, 6, 9, 10. So if I subtract 10 from 11, I still have one more pair of electrons. What am I going to do with that one pair of electrons? Everybody has 8, right? Well, bromine, if you look on the periodic table, excuse me, I wrote this down because I don't have my periodic table with me, which is bad on my part. I should have it, but I don't because I came straight from work. But we have one more, and bromine, is it in energy level 3, 4, 5, 6, or 7? If you look on the periodic table, it's an energy level 4. And one thing I forgot to tell you over here, because I don't know why it skipped my mind, but anything in energy level 3, 4, 5, 6, or 7 could expand its octet because of the access to the d orbitals that are in the energy level below it. Okay, so excuse me. So since bromine will expand its octet, we can actually add some more electrons here, which gives bromine 10 valence electrons. You're going, but Miss Lassiter, you said 8. Okay, well I did, but now we're expanding on it because, like I said in chemistry, every rule and everything I tell you pretty much has an exception to the rule. So it's just they're basic rules, but sometimes they can be cheated a little bit. Okay, so we are in expanded octet. So when you're in an expanded octet, now you come into different shapes. Up until this point, when we had 8 valence electrons on everything, we had 5 different shapes. We had linear, we had bent, we had trigonal planar, trigonal pyramidal, and tetrahedral. Well, since this don't fit into those, now we have another shape. Okay, I'm hearing voices, I'm sorry. Now I have another shape. Okay, so now we have to count regions, electron pair regions. Okay, so I'm going to do this in, let's see if I can do it in blue. Okay, so if we count electron pair, and we're still working with a central atom. Okay, so there's 1 region, 2, 3, 4, 5 regions of electrons. When you have 5 regions, 5 electron regions, electron regions, then you have something that we call trigonal bipyramidal. Can't spell today. Pyramidal. P-Y-R-A-M-I-D-A-L. Okay, I'll get the words right. Okay, and when you have trigonal bipyramidal, there's something else we need to know. It has a hybridization. Okay, and I know you don't have to actually figure this out. You just need to memorize that trigonal bipyramidal has an sp3d hybridization. Okay, you don't need to know how to find it. You just need to know that when you have it, this is your hybridization. And the bond angles on this are 120 degrees and 90 degrees. They both are in there. Okay, so 120 and 90. All right, so have I blown your mind a little bit so far? I hope so, because we're getting ready to do it again, even a little bit more. Okay, so I'm going to go ahead and pause the video while I erase or fast forward, but I'm going to erase this real quick, and we're going to do another one. Like I said, I need a new board. My board is very, 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 very small. So fast forward me at this point until I get done. That way your video is not so long. But it's still going to be shorter than Mr. Cummings. Just kidding, y'all. All right, my board's gonna be kind of dirty, so I apologize. So just ignore it. Just take notes on what you have. Okay, so let's do another one. All right, we have SF6. SF6. Now, sulfur is gonna be our, we already know sulfur is going to be our central atom. And you're gonna go, but Miss Lassiter, it's got 6 things attached to it. Well, yeah, we're gonna expand the octet, can it? Well, sulfur is one of my commonly ones that do this, and it is in the 3rd energy level, so yes, it can access its d orbitals. So we're gonna go ahead and put sulfur in the middle, and then what we're gonna do though is we're gonna add up all our valence electrons. So remember, this is 6 plus 6 times 7 gives me, and I'm gonna cheat a little because I don't wanna mess up, 48 divided by 2 gives me 14. Right? No, 24, sorry, I can't read or do math, apparently, it's late. Okay, so we're gonna add our 6 fluorines on here. F. Okay, I'm gonna subtract 6 from here, and I'm gonna end up with, I'm gonna cheat, there's my 18 more valence electrons that I have to add on. Okay, so right now I'm going to work on fluorine, making sure everybody has 8. There's 8. 8. 8. Oops, I added too many there. Okay, 8. Okay, so now we have 8 on everything. That's 3, 6, 9, 12, 15, 18. So I'm going to subtract my 18. Everybody's happy, happy, happy. Yes, sulfur has more than 8, but we have expanded the octet because it has access to its d orbitals, and we are hybridizing. Now, we have to count how many regions we have. Electron regions. We have 1, 2, 3, 4, 5, 6. So now we have 6 electron regions. This is not trigonal bipyramidal anymore. Now we have something, and I will give you a chart so you can see what they look like when we get back to class. But now we have something that is called an octahedral. Hedral, H-E, can't spell today. Octahedral, H-E-D-R-A-L, octahedral. Okay, so when we get octahedral, we now have a hybrid of sp3d2. Okay, so again, I'm not going to make you find this one, but I am going to have you know that it's whenever it's octahedral, you have an sp3d2. Okay, now the bond angles on all of them are going to be 90 degrees. Okay, so it's very, very has a very unique, distinct shape to it. Okay, so let's take a look at this one, another one real quick. So fast forward the video while I erase this one, because like I said, my board is very tiny. Pause the video if you need to write anything, but fast forward through me while I erase. It will be dirty, just a little bit. Okay, but that's because I'm trying to hurry and get this not so long. Okay. Oh, sorry about that. It's still messy. All right, so let's do the next one that I want to have to for you. We're going to do BR5. F5, sorry, F5. Now, if you look at this, what are you going to think? You're going to probably try to rush through this, and you're going to go, oh, well, if I said, what's the shape of this? You're going to go, oh, wait a minute, there's 5, so it's going to be trigonal bipyramidal. It's going to have 120 and 90 degrees. Well, let's wait and see, because guess what? This has 7 plus 5 times 7, which gives us, and I'm going to cheat because I already did this one, 42 divided by 2, which gives us 21. So go ahead and bring this in, BR, F, 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 F. Okay, so we're going to subtract 5. Subtract 5 from this, you get 16. Okay, Now we're going to add all of our dots, and since it's getting really close, I'm going to put on our F's. There's 3, 6, 9, 12, 15. So I'm going to subtract 15. Did I use up all my electrons? No. Up until this point, we've always had too many, and we've had to take some away and had double bonds and triple bonds and things. Now we have too many. What are we going to do? Well, again, bromine can expand. It already has. So what we're going to do is we're going to add 2 more electrons, another electron pair, which is all of my electrons. Now, what shape would it have? Again, I said you might originally go, oh, it's trigonal bipyramidal. This has 5. Let's see. 1, 2, 3, 4, 5, 6. So it has 6 regions. And 6 regions is going to be octahedral. Okay, octahedral, and have 90 degrees angles. And has an sp3d2 hybridization. Okay, so you got to draw it. That's the key here. You got to draw it. If you don't, you're going to mess up. So in class, we are going to do some more of these. So make sure you have your video notes, because I will probably give you a quiz on this. Okay, have a good night, y'all.